So I will continue our lesson on the properties of the inverse Laplace transform. So in this evening, we will look at the last properties, which is the rational fraction. So before we are using these properties, let's study first what is a rational fraction. So before we start our lesson with the properties of inverse Laplace transform, which concerns about rational functions. So first we will discuss what is a rational fraction. So a rational fraction is a function consists of fraction. For example, you have a function ps over qs. So this is a fraction. So in order to be a rational fraction function, ps and qs must be polynomial. So both ps and also qs must be polynomial. So what is a polynomial? So polynomial is a function consists of a constant and a variable. For example, we have a function. Wait. Okay. Okay. For example, in order to be a polynomial, you must have a constant and a variable. For example, let's say we have a linear function, a polynomial of linear. So in order to be a linear, you must have ax plus b. If I said what is a polynomial of quadratic, so you must have ax square plus bx plus c. A cubic polynomial is ax cubed plus bx square plus cx plus d. So this is a general form. Also, if I have a polynomial of constant only, so I just have a constant a. So in order to be a rational function or rational fraction, ps and qs must be in term of polynomial. So this must be a polynomial function. And then in order to use these properties, let's say we have a function of rational fraction. Let's say we have ax square plus bx plus c over ax plus b. So this fraction we call improper fraction. So improper fraction mean numerator, the power or the highest order of numerator is greater or equal to denominator. What I mean is the power, the highest power. Here we have a second order or quadratic, which is 2. Here the highest power is 1. So improper fraction mean it is greater than denominator. Denominator is 1 while numerator is 2. So we call this one is improper. Or you just have ax plus b over cx plus d. So this is also improper fraction. So we call this improper fraction because the power or the highest power of variable x is equal in numerator and also the denominator. Both are to the power of 1. So we call this one as a improper fraction. To be a proper fraction, what you need to do is you must have the highest power of numerator less than the power of denominator. For example, you have here ax plus b over cx squared plus dx, for example. So this one we call a proper fraction. Remember, we have a fraction consists of numerator and denominator, and the power here is 1 while the denominator is 2. So this one we call the proper fraction. So in order to do a Laplace transformation, you must convert improper fraction to proper fraction. So you must convert this improper fraction to proper fraction. So how to convert from improper fraction to proper fraction? So you are using long division. So you must use a long division to convert from improper fraction to proper fraction. So how to do the long division? For example, let's say we have 2s squared plus s plus 1 divided by 2s plus 1. So here our rational fraction is improper fraction because the highest power in numerator is square, is 2, while the highest power in denominator is 1. So 2 is greater than 1, hence this is improper fraction. So we are going to use the long division to transfer or to transform this fraction into proper fraction. So in order to use the long division, so you need to write this fraction into the division form. So 2s squared plus s plus 1 divided by 2s plus 1, all positive numbers, and then we will multiply with s. So I will have 2s squared plus s, so minus. So 2s squared minus 2s squared 0, s minus s 0, and I will have 1. Alright, so that's it. Then how to write our proper fraction? So you will write according to this way. So s plus 1 over 2s plus 1. So this will be our proper fraction, while this is our improper fraction. So you have changed from this form to this form, from improper fraction to proper fraction. So let's continue with the inverse of Laplace transform. So first, if we have a rational function, first thing is make sure that you have a proper fraction. So how to do the proper fraction? You do by using a long division. After you get a long division, after you done the long division, then you have a proper fraction. Then what you need to do is you need to factorize the denominator into its prime factor, its prime factors. So let's check the denominator. So the denominator is a polynomial below the function or the fraction. If we have a over b, so what you need to do is you need to check a function b. For example, you have a s over bs, so you need to check what is a bs. So if our bs, if the function bs is a linear factor, you have a linear factor ax plus b to the power of n. So we have ax plus b to the power of n. So this is a linear where the power is equal to n. So what you need to do is we need to break down this fraction into several fractions. So you write because we have a linear factor, then the numerator, in order to be a proper fraction, you must have a power less than 1. So because this is a linear, you have x to the power of 1. So the numerator must be a constant, ax to the power of 0, or just a. So the power here must less 1 than the denominator. So because we have to the power of n, first we write the first constant, let's say a1. So a1 over ax plus b plus a2, another constant that we want to find this one after this. So first write a1, one constant, over ax plus b plus another constant a2, which we will find what is a1 and a2 later, over ax plus b squared plus a3 over ax plus b to the power of cube, and you will plus until you reach at the end of the power, the highest power equal to n. So this is the last power, which is n. So this is how we break a linear factor. If we have denominator, for example, in the denominator as over bs, if denominator bs, if bs is a linear factor, two linear factor ax plus b times cx plus d, so you want to break down this fraction into this one. So because we have a linear factor, then the numerator must less than 1, power must less 1. So because this is ax, so here must be a. So constant a over ax plus b for the first factor, plus b, another constant, over cx plus d. Next, if the denominator, if as over bs, where bs, if the denominator is a quadratic factor, which the power is n, it is a quadratic and the highest power to the n. So you want to break down into several fractions. So the first fraction start with ax plus b. So because the denominator is a quadratic, so numerator must be a linear. The power here 2, so the power here must be 1. So you will have a first linear over ax squared plus bx plus c, which is, this is a power 1, plus a second fraction, another constant a2x plus b2 over ax squared plus bx plus c to the power of 2, and then you will add up this fraction up to the power of n. Lastly, the power must be equal to n. So you will have several fractions add up together. Later on, you will solve this to find what is a constant a1, b1, a2, b2, an, bn. Alright, let's see this one first. This example. Find the inverse Laplace transform for the following function. First, we have fs equal to s minus 3 over s minus 2. So number 1, find the inverse of this fraction, s minus 3 over s minus 2. So first thing, you must check whether this fraction is proper fraction or improper. So proper fraction means the power here must less than the power here. The power of numerator must less than the power of denominator. So here the highest power is 1. here we have s multiply s. So s squared. So the power here is 2, here is 1. So this is a proper fraction. Remember, if this is not proper fraction, you must do a long division. So now this is a proper fraction. Then first you need to do is you must break down this fraction into several fraction, additions of several fraction. So observe the denominator. So in denominator, we have a factor. First, we have s. Second, we have s minus 2. So you write the denominator. It consists of one fraction where the denominator is s. Another fraction is s minus 2. For numerator, the power must less than 1. So here the power is s to the power of 1. So the numerator must be less than 1. So because this is a linear, so numerator must be a constant. A s0. So a s0 is a. So here we have a constant a. Second, the constant must be also a linear because here is linear. So the second constant must also be a constant b. Alright, so this fraction actually came from s minus 3 over s minus 2. So now we want to solve for a and b. We want to find what is the value a and b. So you expand this fraction. So s minus 3 over s minus 2. This is equal to, so how to expand this one? So a will multiply with s minus 2 over s minus 2, while b will multiply with s. So you will have a times s minus 2 plus b times s over s times s minus 2. So a times s minus 2 plus b times s. So because the denominator here s times s minus 2, here also s times s minus 2, that means these fractions are equal. So if the denominator are equal, so then the numerator. So the numerator is s minus 3 equal to a times s minus 2 plus bs. So from here, you will solve the simultaneous equation. So you will solve a simultaneous equation to find what is the value for a and what is the value for v. So in order to solve the simultaneous equation, you have two methods. First one is you expand this fraction and this multiplication. For example, so here you have as minus 2a plus bs equal to s minus 3. And then we will regroup the variable we have. Here we have as plus bs. So you have a plus b multiply s minus 2a. Here you have s minus 3. So now from here, let's see the coefficient. So here is s, here is also s. That means a plus b equal to 1. And here you have minus 2a, here you have minus 3. That means minus 2a equal to 3. So from here you can write two equations. Let me write here. A plus b equal to 1. Equal to 1 is one equation. Minus 2a equal to minus 3. Another equation. So solve for a and b. So from equation number 2, you know that a will be minus 3 over minus 2. And from equation 1, b equal to 1 minus a. So 1 minus, here will be 3 over 2. So 1 minus 3 over 2, which is equal to minus 1 over 2. So from here, we know that a is 3.2, b is negative 1 over 2. This is one method. This is method number 1. You can use this method in order to find a and b. But for me, I like to use a second method. Let's start from this one. So this is method number 2. Method number 2 to find the value for a and b. So for this method, you will substitute s for a number that will make your equation become easy. For example, you see this equation, we have s minus 3 here equal to a times s minus 2 plus bs. So first, in order to find the value for a and b, let's find one number. Let's find s equal to, what number you want to find is whatever make the function here or function here equal to 0. For example, here we have s minus 2. So what make this one equal to 0? S equal to 2. So let s equal to 2. So if here equal to 2, that means 2 minus 2 will be 0. So this one is 0. Here will be 2. 2 minus 1 is, 2 minus 3 is minus 1. A will become 0. B will become 2b. So b is negative 1 over 2. Now, let's find another constant. Let's substitute s to, how to make this one equal to 0? Let's say this s equal to 0. If this s equal to 0, then 0 times b is 0. So you can cancel this one. 0 times 2 is 0 times 2, 0 minus 2 is minus 2. 0 minus 3 is minus 3. So you will have minus 3 equal to a times minus 2. So solve for a is 3 over 2. So which one is more simple? I think method number 2 is more simple. So method number 2 is more simple, kan? So you don't need to expand this fraction. So now we know that a is 3 over 2, b is minus 1 over 2. So you substitute back the value for a and b into this fraction. So let me erase this one first. Let me bring this equation to the below. Okay, so here. A is 3 over 2, b is minus 1 over 2. So this fraction equal to 3 over 2 over s minus 1 over 2 over s minus 2. So now this is equal to fs. So you have break down fs from this fraction into simple fraction. If you add up this fraction, you will get back to this fraction. So now this is the fraction that you already make it simple. So now we want to find the inverse Laplace of function s. So by using a linear properties, this is equal to inverse of 3 over 2 over s minus inverse Laplace of 1 over 2 over s minus 2. Next, we have a constant here, so you can pull out the constant outside. So you will have 3 over 2. Inverse of here will be 1 over s. Here also have constant, so we can put the constant outside. And we have here s minus 2. So s minus 2 is exponent 2t. So exponent 2t you can put outside. Here will be just s. So let's take out 1 over 2 and take out exponent 2t. So here you have 1 over s. So 3 over 2, inverse Laplace of 1 over s is 1. So 3 over 2 times 1. Minus 1 over 2 exponent 2t time inverse of 1 over s is also 1. So final answer is this one. 3 over 2 minus 1 over 2 exponent 2t. So this is a solution for the first rational fraction. And let's say another example. So here we have s plus 1 over s plus 2 times s minus 1. So question number 2. Fs equal to s plus 1 s plus 2 over s minus 1. First thing is check this fraction, whether it is proper fraction or improper. So here the highest power is 1. Here is 1 times 1, 2. So 1 over 2. So this is a proper fraction. Then from this fraction, you need to break down first. Break down this fraction to simple fraction. So because here we have a linear factor, here also factor of linear, so this should be s plus 2 over s minus 1. So for the numerator, the power here must less 1. So let's take a constant a, here also constant b, another constant b. So you have a simple fraction a over s plus 2 plus b over s minus 1. And then in order to solve for a and b, you need to expand this one. So we have s plus 1 over s plus 2 over s minus 1. So we have here for a, you must multiply with s minus 1. For b, multiply with s over 2. So here we have s plus 2, s minus 1. Because the denominator are equal, so the numerator also equal. That means we have s plus 1 equal to a times s minus 1 plus b times s plus 2. Right, so we want to find for a and b. So here, I would like to use a method number 2 to find the value for a and value for b. So first, in order to find a, I must make sure this one goes to 0. So how to make sure this one goes to 0? S should be minus 2. Minus 2 plus 2 is 0. So this one 0. So that this one will be 0. So let S equal to minus 2. So minus 2, substitute into this equation. So minus 2 plus 1 equal to minus 1. Minus 2 minus 1 minus 3. So A times minus minus 3. So A equal to minus 1 divided by minus 3. So this one equal to 1 over 3. So I have a value for A. Next, to find the value for B. So I want to make this one goes to 0. So let S equal to 1. So because S equal to 1, 1 minus 1, so this one is 0. Here also 1, 1 plus 1 equal to 2. So let S equal to 1. So we'll have 1 plus 1 is 2. 1 minus 1, 0. So A is 0. B, 1 plus 2 is 3. So B equal to 2 over 3. So I have A 1 over 3, B 2 over 3. Substitute back into this fraction. So we have Fs equal to 1 over 3 over S plus 2 plus 2 over 3 over S minus 1. From here, you substitute A 1 over 3, B 2 over 3. So you have this one. Hence, we want to find an inverse Laplace of Fs. So this one is inverse Laplace of 1 over 3 over S plus 2 plus inverse Laplace of 2 over 3 over S minus 1. So let's copy this one first. Okay, continue from here. So 1 over 3, we can put outside. Take out 1 over 3, put outside. And then S plus 2. So S plus 2, by using second properties. So if we take out outside, this will become exponent negative 2t. So exponent negative 2t. So in the bracket, we have 1 over S. Next, we have 2 over 3 exponent t. So we have inverse of 1 over S. So 1 over 3 exponent minus 2t. 1 over S is 1 plus 2 over 3 exponent t. 1 over S is 1. So this is our answer. Number 3, S plus 2 divided by S squared minus 3S plus 2. S plus 2 over S squared minus 3S plus 2. S squared minus 3S plus 2. S squared minus 3S plus 2. Okay. Okay, check the denominator. and the numerator. So here we have power 1, here we have power 2, so this is already in proper fraction. So this one is already in proper fraction. Next, we want to break down this equation, this fraction, into more simple equation. In order to make a simple equation, check the denominator first. Can the denominator you factor this one? If we want to factorize this one, yes, this one will be s plus 2 over s minus 1, s minus 2. So s plus 2 over s minus 1 times s minus 2. So from here, rewrite this one as addition of a over s minus 1 plus b over s minus 2. So here must be a constant because here is a linear. Here must be also constant, another constant because this one is a linear. So now we have our function s plus 2 over s minus 1, s minus 2. So in order to solve for a, you need to expand this fraction. So we have s plus 2 over s minus 1 times s minus 2. This one should be a multiply s minus 2 plus b multiply s minus 1. S minus 1, s minus 2. Now, both fractions are equal. Denominator here are equal. And because this is equal, that means here and here must also equal. So you have s plus 2 equal to a times s minus 2 plus b times s minus 1. Next, solve for a and b. So let s equal to 1. So if 1 here, 1 minus 1, 0. So here it will be 0. So 1 plus 2 is 3. So let s equal to 1. So 1 plus 2 is 3. A, 1 minus 2 is minus 1. B is 0. 1 minus 1 is 0. So here A is negative 1 over 3. Sorry. 3 divided by minus 1. So minus 3. Let s equal to 2. So if s equal to 2, here will be 0. So 2 plus 2 equal to 4. A is 0. 2 minus 1 equal to 1. So B equal to 4 divided by 1. So B is 4. So now our fraction Fs are A is minus 3. So we have minus 3 over S minus 1 plus 4 over S minus 2. So to find an inverse Laplace of Fs, so this one is inverse Laplace of minus 3 over S minus 1 plus inverse Laplace of 4 over S minus 2. So minus 3, put outside. Here we have S minus 1. So put outside will be exponent t. So inverse Laplace of 1 over S plus 4 S minus 2. If we put outside, here will be, put outside will be exponent 2t. So exponent 2t 1 over S. So we have minus 3 exponent t plus 4 exponent 2t. 1 over S is 1. Right. Example 1, 2, 3 both lebih kurang, ya kan? Okay, example number 4. Example number 4, fs equal to s over s minus 2 s square minus 1. This one different sikit lah. Example number 4, fs equal to s over s minus 2 s square minus 1. S square minus 2 s minus 1. Ke terbalik. S minus 2 s square minus 1. S minus 2. S minus 2 s square minus 1. Okay, so check whether this is proper or improper. So here power 1, here must be power 3. So this is proper fraction. You must check if this is improper, do the long division to get a proper fraction. Next, we will break down this equation. So we have, okay, check this one first. Is this function, can you factorize? Yes, this one actually you can rewrite as s plus 1 s minus 1. So if you expand, you will get s square minus 1. So this actually are s over s minus 2 s plus 1 s minus 1. So we have 3 fraction. Both, all 3 are linear. So we have a plus b plus c. Here we have s minus 2, s plus 1, s minus 1. So this one equal to s over s minus 2, s plus 1, s minus 1. Okay, next, in order to expand this one, so a will multiply because a already have s minus 2. Check this one. How to multiply, how to expand this fraction. So first you check a. A is s minus 2. So here you have already minus 2. What you don't have is s plus 1, s minus 1. So a will multiply with s plus 1, s minus 1. B, what B have? B already have s plus 1. B already have this one. So B must have s minus 2, s minus 1. So you multiply B's. B is s minus 2, s minus 1. C, so C already have s minus 1 here. So s minus 2, s plus 1. C times s minus 2, s plus 1. So here will be s. So here we have s minus 2, s plus 1, s minus 1. Here you have s minus 2, s plus 1, s minus 1. So because the numerator, the denominator are equal, same, that means this one are equal with this one. So you can rewrite s equal to a s plus 1 s minus 1 plus b s minus 2 s minus 1 plus c s minus 2 s plus 1. Okay, look like you have a lot of S, you need to find. But don't worry, because you only have 3 constant. You only have to find 3 constant. So in order to find these 3 constant, because everything you have a fraction, you have a factor here. In order to find either A, either B, or either C, you must make sure at least one goes to 0. At least one goes to 0. For example, I want to find A. If I want to find A first, I need to make sure B and C goes to 0. So let's see what B and C have in common. So here they have S minus 2. Here also have S minus 2. So if I want to make this equal to 0, I put S equal to 2. If I put S equal to 2, here 2 times 2 minus 2 is 0. 2 minus 2 is 0. S is, let S equal to 2. So now we have 2 equal to A times 2 plus 1, 2 minus 1. So we have, here equal to 2 lah. So we have 2 equal to A times 2 plus 1 is 3. 3 times 1 is 3. So A is 2 over 3. Now I want to find B. So if I want to find B, I need to make sure A and C goes to 0. First, let's find what A and C have in common. We have S plus 1 here, we have S plus 1 here. So now let's make S equal to minus 1. So let S equal to minus 1. So if S equal to minus 1, so here will be 0. Here also 0, because here we have 0, 0. Here will be minus 1. B minus 1, minus 2, minus 1, minus 1. So we have minus 1 equal to B minus 1, minus 2, minus 3, minus 1, minus 1, minus 2. So here positive 6, minus 1. So B equal to minus 1 divided by positive 6. So B is like minus 1 over 6. C. Now we want to solve for C. So find what A and B has in common. So we have S minus 1, S minus 1. So let S equal to 1. So let S equal to 1. So if I have 1, 1, 1, this one 0, 0, here will be 1. So I have 1. C, 1 minus 2, 1 plus 1. So 1 equal to C times 1 minus 2 is minus 1. 1 plus 1 is 2. So minus 2. C equal to 1 divided by minus 2. So negative 1 over 2. Now, you know A, B, C. So substitute into this equation. So let me make it smaller. So we have Fs equal to 2 over 3 over S minus 2 plus negative 1 over 6 over S plus 1 plus C is negative 1 over 2 over S minus 1. Okay, let's copy this one first. Next page. Paste this one. Okay. So find the inverse Laplace transform of Fs. So this one equal to inverse Laplace of 2 over 3 over s minus 2 plus inverse Laplace of minus 1 over 6 over s plus 1 plus inverse Laplace of minus 1 over 2 over s minus 1. Next, using a properties, so we have 2 over 3 exponent 2t inverse Laplace of 1 over s plus, here we have negative 1 over 6, so minus 1 over 6. S plus 1 is exponent minus t inverse Laplace of 1 over s plus 1 minus 1 over 2 exponent t inverse Laplace of 1 over s. So we have 2 over 3 exponent 2t minus 1 over 6 exponent minus t minus 1 over 2 exponent t. Okay, so that is our final answer. Okay, let me find another example yang bagi jawapan yang lain-lain sikit lah. Okay, so these three are quite different. I hope we will solve this one. We will get another different answer lah. Okay, so here you have S. Okay. Number 1. Another example. Let's say I call this one number 1. Fs equal to s minus 2 s squared plus 3. Okay, so to solve this equation, to solve this partial fraction, you need to break down this into simple fraction. To find the inverse Laplace of this fraction, because this is a fraction, so you must break down into simple fraction. So observe the denominator. Here we have s squared. Here we have s plus 3. Okay, so you can rewrite this one as two function. Or, okay, first you have two methods. You have two methods. First one, you can break down this one as a s plus b over s squared, because we have a quadratic equation here, so you must have a linear equation in the numerator. So you have as plus b over s squared plus, then because this is s plus 3, so here you have s plus 3. For linear, here you have constancy. So you may have this kind of fraction. This is number 1. Number 2, because this is actually s square, actually you can rewrite this as here. You can rewrite s square. Actually, this is a linear, repeated linear function, s to the power of n, where n is a number 2. So you can rewrite this as a over s plus b over s square. plus c over s plus 3. So you can rewrite as 2 function. Because this is a repeated function, repeated linear function. Because s is a linear function, it repeated 2 times. So first you write a over s, second b over s square. The power from 1 to the power go to 2. So which one is correct? Which fraction, number 1 or number 2? Which one is correct? Both are correct. This one also correct. This one also correct. If you want to solve for Laplace, which one is more easier? Number 1 or number 2? The more easier will be number 2. Why? If we take Laplace, for example, for this fraction, you find a and b. Then here you need to separate as two functions. As over s square plus, from here, if you want to use this number 1, I take here, if you want to take an inverse Laplace of as plus b over s square, so you need to break down into two fractions. So you have inverse Laplace of as over s square, this one is number 1, plus inverse Laplace of b over s square. Then as over s square, because we have common factor, so this one will be a over s. So sama aja kan? You see ya, from here you came to here, sama macam number 2. So either you do number 1 or number 2, but I think you do number 2 terus lah. Tak perlu nak do number 1. So if you do number 2, you will get this one, and when you want to find an inverse Laplace, you already get this form. A over s, b over s square. Okay, so let me delete all this one. Okay, so let's proceed with number 2. So this one, I can rewrite as this one. So s minus 2 over s square, s plus 3 also can be broke down into simple fraction. A over s plus b over s square plus c over s plus 3. Then we need to expand this fraction. You need to expand this fraction to find the coefficient for s minus 2 and a, b, and c. So this one you can, okay, check for number 1. You have a over s. You already have s. So compare with this one. What you have is already s. What you don't have is s plus 3. Yeah? We only have s. So we don't have s times s plus 3. If we time multiply this one, you will get this one. So that means a multiply s multiply s plus 3. So you need to multiply 1s and s plus 3. So after you multiply with this one, you will get same with this one. Okay, check for b. B already have s square. So b already have this one. So b don't have s plus 3. So b must multiply with s plus 3. C already have s plus 3. So already have s plus 3. That means c multiply s square. So here I just make it more simple. I don't need to rewrite again this one, because I know that if I expand this one, I will get s minus 2 equal to this one. So a times s plus 1 plus b times s plus 3 plus c times s squared. Now we want to solve this one. Okay, so let's solve for a first. In order to find a, you need to make sure b and c equal to 0. So in order to find a, you make sure b and c goes to 0. So if I let, so this one goes to 0 when s equal to 0. But if s equal to 0, this one not goes to 0. Okay, so you can choose whatever value you want to use for s. For me, first I can solve for c. Yeah, we solve not in order. First we solve for c, because if I take s equal to 3, b will be 0, a will be 0. So let s equal to minus 3. So minus 3 here will be 0, here will be 0. So let s equal to minus 3. So minus 3 minus 2 is minus 5. A0, B0, C will be minus 3 square. So 9. So C is minus 5 over 9. Next, okay, let's solve for B. So if I choose S equal to 0, here will be 0. If S is 0, A will be 0, C also 0. So I can find for B. So let, not B, let S equal to 0. So if I let S equal to 0, 0 minus 2 is minus 2. A will be 0. C will be 0. So I have B 0 times 3. 0 plus 3 is 3. So B is minus 2 over 3. Okay, now to find for A, because in order to find A, you cannot make B and C goes to 0. You cannot make this one goes to 0 because B and C doesn't have a common factor. So what you can do is you just choose whatever value you want. Let's choose a smaller value. Let s equal to 1. So if I have s equal to 1, so 1 minus 2. So 1 minus 2 is minus 1. A we don't know, so we write A. Then we have s equal to 1, 1 plus 3. B, we know that B is minus 2 over 3, so write value for B. Then S is 1, so 1 plus 3. C is minus 5 over 9. Let me make it smaller. So C minus 5 over 9. Then we have S squared. So multiply by 1. So solve this one. So we have minus 1 equal to 1 times 4. So 4A minus, so 1 plus 3 is 4. 4 times 2 minus 8 over 3 minus 5 over 9. Okay, solve for A. Find the value for A. So we have -1 plus 8 over 3 plus 5 over 9 divided by 4. A is 5 over 9. So substitute into Fs. So Fs, A is 5 over 9 over S. B is -2 over 3. Oh, sayang. 5 over 9 minus 2 over 3 S square. C is -5 over 9. So -5 over 9 S plus 3. Okay. Next, find the inverse Laplace of Fs. So by using linear properties, we have inverse Laplace of 5 over 9 times S minus inverse Laplace of 2 over 3 over S square minus inverse Laplace of 5 over 9 S plus 3. Okay. So from here, 5 over 9 you can put aside. So here we have 1 over S. 2 over 3 we can put outside. So we have inverse of 1 over S square. S square is 1 plus 1 kan. So here will be, should be multiply 1 factorial. So doesn't change anything lah, because here divide by 1 factorial, so doesn't change anything. Here 5 over 9 S plus 3, so exponent minus 3t. Inverse Laplace of 1 over S. So we have 5 over 9 times 1 minus 2 over 3. Here will be t minus 5 over 9 exponent minus 3t. Okay, that's it. So 5 over 9 minus 2 over 3t minus 5 over 9 exponent minus 3t. Okay, a little bit difference from the first three. Next, number 2. Let's do number 2. S plus 1 over S plus 2 square minus S minus 1. S plus 1, S plus 2 square, S minus 1. S plus 1, S plus 2 square, S minus 1. Okay, correct. Okay, so we want to break down this fraction into a simple fraction. This one is already in proper fraction because this is only power 1. Here we have S square, so 2 times 1. So this one is 1 over 3, yeah, the power. Here power 1, here power 3. So this one already improper fraction. We don't have any improper fraction to show you the example. I don't have any example with improper fraction. Okay, so let's break down this fraction into simple fraction. First, let's observe the denominator. Here we have a linear repeated 2 times. So you must have first power 1, s plus 2 power 1. Second, you must have s plus 2 power 2. Repeated 2 times. If repeated 3 times, plus another s plus 2 to the power of 3. Ya. Kalau ada lagi lah. But because we have only 2, so just write s. Then s minus 1. Here we have a constant because this is a linear, so here we have a constant a, here constant b, here constant c. Everything are constant. A over s plus 2 plus b over s plus 2 squared plus c over s minus 1. So this is equal to s plus 1 over s plus 2 square s minus 1. Next, you need to expand this one. So first, we write this one as s plus 1. For a, what factors that a need to multiply? So let's observe what a has. A have 1 of s plus 2. It have power 1. Here, we have power 2. So it lacks another s plus 2, s minus 1. So this one is what A lacks. B already have s plus 2 square. So what B doesn't have? S minus 1. So B needs to multiply with s minus 1. Plus C already have s minus 1. So already have s minus 1. So C needs to multiply with s plus 2 square. A times s plus 2, s minus 1, B times s minus 1, C times... Okay, correct. Now, find A, B, and C. So if you want to find A, B, and C, as I told you earlier, you have two methods. If you want to expand this one, also can. Method 1, you expand this one. Expand lah. S plus 2 times s minus 1. So you get one quadratic equation. S minus 1 times B, you get one linear. This one you have squared, so this one expand and then make here equal to whatever s you have, 1 equal to whatever constant you have, and then do the simultaneous equation. Or method B, let's choose a value for s. Okay, let's find whatever value that we can find more easy. First, let's solve for C. Yeah, I think that if I choose s equal to 1, A will be 0, S also will be, and B also 0. So let S equal to 1. So if this one 0, so we have 1 plus 1 equal to 2. A became 0, B became 0. So 1 plus 2 is 3. 3 square is 9. So C equal to 2 over 9. Then solve for A. Yeah? If I choose A, if I choose S equal to minus 2, A will be 0. C also 0. Minus 2 here will become 0. Minus 2 here will become 0. So minus 2 plus 1. So let S equal to minus 2. Minus 2 plus 1. Minus 1. A 0. B will be minus 2 minus 1 minus 3. C 0. So B is minus 1 over minus 3. So 1 over 3. And then after you choose everything now, for find A, you cannot make B and C goes to 0. So let's choose a smaller value for S. Let S be 0. Let S equal to 0. So if 0 plus 1, you have 1. A, you have 0 plus 2 is 2. Multiply 0 minus 1 is minus 1. Plus B, B is 1 over 3. Multiply 0 minus 1, minus 1. C, sorry, C we know the value already. C is 2 over 9. 0 plus 2 is 2. 2 square is 4. So we have 1 equal to minus 2a minus 1 over 3 plus 4 over, no, 8, 8 over 9. So a equal to 1 plus 1 over 3 minus 8 over 9 divided by minus 2. So a is minus 2 over 9. So substitute A, B, and C into this one. So we have Fs equal to A is minus 2 over 9 over S plus 2. B 1 over 3 over S plus 2 square plus C is 2 over 9 over S minus 1. Find inverse Laplace of Fs. So inverse Laplace of Fs, so we have inverse Laplace of minus 2 over 9 S plus 2 plus inverse Laplace of 1 over 3 S plus 2 square plus inverse Laplace of 2 over 9 S minus 1. So we have minus 2 over 9, you can put outside. S plus 2 is exponent minus 2t. Then we have here 1 over S. 1 over 3 we can put outside. S plus 2, how to put outside? Exponent minus 2t, same thing. Then you have here is 1 over S square. S square. S square is 1 plus 1. 1 plus 1. So here should be 1 factorial. So here divide by 1 factorial. Doesn't change anything because divide by 1. Then for here you have 2 over 9. S minus 1 is exponent t, inverse of 1 over S also. Okay. So we have minus 2 over 9, exponent minus 2t, 1 over S is 1. Plus 1 over 3, exponent minus 2t, 1 over S square is t. T to the power of 1. Plus 2 over 9, exponent t. Okay, so we have another 5 minutes. Let's solve last one. I think this one is the last. Okay, so this one is the last one. So let's solve the number 3. Number 3 is s square plus 2 s times s square plus 1. Number 3. So fs s square plus 2 s times s square plus 1. Okay, look at the denominator. Here we have numerator power 2. Here we have power 3. So already in proper fraction. So let's rewrite this one. First, we have s. Second, okay, check this one. S square plus 1. S square plus 1. Can you do in factorized form? If you cannot factorize this one, you don't have any factorized form. If s minus 1, s minus 1, you get s square plus 1. Sorry, minus 1. This one, you have s minus 2, s plus 1, not equal. So, this one, s square plus 1, you don't have any factorized form. This one, you don't have any factorized form. No. So we are going to write this as also s square plus 1. Because we don't have any, you cannot simplify into more simple form. You cannot factor. Alright, so now let's rewrite the numerator for s. Because this is a linear, so numerator will be constant a. For s square plus 1, because this is quadratic, the highest power is 2, so you need to rewrite as linear. So we have a, so next bs plus c. Must a linear, because this is a quadratic, here must be linear, less than 1 power. So here we have s square plus 2 over s square plus 1. So s square plus 2 equal to a multiplied by s square plus 1 plus bs plus c multiplied by s. Okay, we want to solve for a and b. A, b, and c. You have three constants a, b, and c. bs plus c. Okay, let's use the method that I have discussed earlier. Can we solve by using the method? Can we make it any constant a, b, or c goes to 0? Yes, if I put s equal to 0, here 0, b, and sorry. If I put s equal to 0 here, this one will be 0, then I can find the value for a. So let s equal to 0. So 0 square plus 2 equal to 2. 0 plus 1, so we have 1. bs plus c, so b times 0, 0 plus c, s times 0, so this one already 0, so we have a equal to 2 divided by 1, a equal to 2. Next, find for b and c. So because we cannot make it a goes to 0, a cannot be 0. Because whatever number we have here, you cannot make it this one equal to minus 1. Because we already squared it. So let's choose a smallest s. S equal to 1. So if s equal to 1, so I will get here 1 square is 1. 1 plus 2 is 2. A is 2. 1 square is 1. 1 plus 1 is 2. So S is 1, so we have B plus C so I have B plus C times 1. So I have 2, 4 plus B plus C. So we have one equation. Then let S equal to minus 1. So minus 1 plus 2 and minus 1 square plus 2. Here should be 3, right? Here should be, so 3, yeah? Minus 1, sorry, 1 plus 2 is 3. Here is 1 plus 1, 2. So 2 times 2, A is 2, 4. 1, B plus C. So, okay, so here is equation number 1. Equation number 2, let S equal to minus 1. So we have minus 1 square is 1. 1 plus 2 is 3. A is 2. Minus 1 square. Minus 1. So we have 2 plus minus B plus C times minus 1. So we have 3 equal to 4 minus B plus C. So here we have plus B minus C. So here is equation number 2. Next, from here, from equation number 1, we have B equal to 3 minus 4 minus 1 minus 1 minus C. So B is 3 minus 4 minus 1 minus C. Okay, so B is minus 1 minus 3. So substitute B into equation. Substitute B equal to minus 1 minus C into equation number 2. So we in equation number 2 we have 3 minus 4 minus 1 equal to B minus C. So B equal to so we have minus 1 equal to minus 1 minus C minus C. So we have minus 1. We have minus 1 minus 2C. So minus 2C equal to minus 1 plus 1, 0. So C equal to 0. So because C equal to 0, B equal to minus 1. All right. So I have A is 2, B equal to minus 1, C equal to 0. So substitute back into this equation. So substitute back into A over S plus BS plus C. So let's copy this one first. So we have A minus A2, B minus 1, C 0. So A is 2 over S, B is minus 1, so B is S, C is 0, so S square plus 1. So this is equal to Fs. So 2 over S minus S over S square plus 1. Okay, so find the inverse Laplace transform of Fs. So inverse Laplace of 2 over S minus inverse Laplace of S over S square plus 1 square. Here will be S square plus 1 square. So we have 2 inverse Laplace of 1 over S minus S over S square plus 1 square. So we don't change anything here. So here will be 2 minus cos t. So the answer is 2 minus cos t. Alright, so I already covered the rational function. So last last chapter or last subtopic of Laplace transform is initial value. So we are going to use the Laplace to solve the differential equation. Alright, so I think that's all for this evening. So after this, I will share the video. I will edit the video and upload to the YouTube. So I will share to you later on. So those who absent, I hope you can study lah. Same goes to you yang datang malam ni ya, yang attend to this class tonight. If you didn't catch something, please refer back to the video that I will show for you later. Okay, with that, I think that's all. Thank you.